power system overview. First, first you need the what are the components. First, power generation. That is power generation, transmission, distribution, switchgear, protection. Okay, they are the methods. First one is power generation, transmission, distribution, and switchgear protection. Okay, so switchgear protection. So okay, switchgear protections. So these are the next. So we'll go for the first generation. So generation will have the types. So electricity generated by converting the different natural available resources like coal, wind, solar energy. Okay. Next. So how how power is generated? First, so we'll having the energy gas. Okay, source of energy. So we need to generate the power. We need the one prime mover and one generator set. So generator converts the mechanical energy to electrical energy with the using of the prime mover mechanical. So here we are using the prime mover as a turbine. Okay, here generator. So generator we are using the that is DC generator or AC generator. So here to give the mechanical source, that is sources, we are using the different types of sources, that is coal, thermal, nuclear, different sources there. So here kinetic energy, okay, whatever the sources we are using, that we will have to convert that energy into the mechanical energy. That mechanical energy converts to the electrical energy here. Okay. Now, so classification of energy sources here. So to generate the power, so we need the source energy sources. That sources are classified into two types. That is conventional energy sources, another is non-conventional energy sources. Here in conventional energy sources we have different types. So conventional sources like solid, liquid, and gaseous fuels. Okay, solid fuels are having the coal, wood, and liquid fuels heavy oil, diesel oil, petrol oil. Okay, so in solid fuel have nuclear components also. Okay. Gaseous fuels, natural gas, petroleum gas, and next water. So hydropower also comes under the conventional. So conventional sources which are we have used, whatever we are using, after some time it will be not available. And conventional which gives the net energy pool, that is called as a conventional energy sources. Okay, here from solid fuels we get the net power, from liquid fuels we get the net power source. Okay, in gaseous fuels we get the net power energy sources. In here from water, okay, here we cannot burn the water, but whatever the water energy source is there, that kinetic energy is transferred to the mechanical, from mechanical to electrical here. So another one is a nuclear. So by using the nuclear fission and fusion process, the chain reaction will be also transferred to the heat. That heat is will be from heat to the next kinetic energy of the water. Okay, so here kinetic energy that will be comes from the steam. Okay, heat, water will be heated, that will be converted to the steam. The steam goes to the turbine, that will convert to the mechanical energy to electrical energy. Next, non-conventional resources. Okay, non-conventional also we have different solar, ocean tides and waves. Okay, here solar. So by using solar rays we are generating the power, that is a non-conventional. So it will be available at non-conventional sources which cannot generate from net energy source, that type of non-conventional. So from solar we can generate for only morning times, so after night times we cannot generate. Okay, here ocean tides and waves. So here also we cannot generate the net energy. So whenever the tides and waves comes, that only situation generate the power here. Next, wind energy. So wind energy, by using wind energy, so what are the wind energy then, that will convert to the by using the wind turbines. Okay, by using the wind turbines we convert the that wind force to the wind turbines to mechanical, from mechanical to electrical energy conversion take place. Okay, here from geothermal. Okay, geothermal, here geothermal, by using geothermal, so we'll drill into the well, bore wells to the here, and here up to the magnet of the earth. So we throw the water to the magnetar, then so the heat, whatever the heat is there from the earth, okay, so when we flow through the water into the heat, the magnetar, so the water will be converted to the steam by using the heat energy of the earth crystal, okay, that steam will be using to the rotate the turbine, okay, that turbine will start to generate the power, okay, that is the geothermal. Next, so in villages and by using the vermicompost, different methods, by different productives, we generate the biomass, so or biogas. By using biogas also we generate the power, okay, so whatever the power is there here, biomass is there, okay, here to generate the heat we are using the biomass or biogas, okay, the main thing is that we are going to convert the heat energy into the steam, that steam is converted to give to the turbines, okay. Next, here ocean thermal energy conversion, that is OTEC, okay. So here whatever the energy is there, okay, from a normal morning days, okay, so due to the sunny, due to the sun, the days will be heated, that heat energy converts to the energy source, okay, to generate the power. Next, we have the fuel cell. So fuel cells, natural fuel cell is there, that will be converted to the electrical energy, okay, magnetohydrodynamics, okay, this also comes under the here in magnetohydrodynamics here. So we give the, we flow the gas through the two different magnets, that is north pole, south pole, okay, here heavy magnets will flow, here the gas will be flown through between the two magnets, here the energy will be developed from the magnetite, okay, that is the one type, that is magnetohydrodynamics generation. Next, thermoelectric. So these are thermoelectric, so by using different energies, that is one is cold, another is salt, okay, heat and cold, so by using this one we generate the power, that is the thermoelectric. Next, piezoelectric. So piezoelectric device which generates the power by using piezoelectric cells, okay, here this is power generation, okay. So we can go for the next topic, that one is transmission, okay. Here this is the power generation. After generation we go for the whatever generated is there, that will be converted to give you the transmission line, okay. Here, so the generation is generated, that is 11 kV, that 11 kV we can transfer by using the transformer, okay. So through the transmission line, before the transmission line we step up the voltage, that voltage is 132 kV, 400 kV, different types, okay. So here what we're using, that is a type. So here we go for the C, you can easily understand here. Okay. So whatever we have, so you can observe that. So here, okay. So here, yes, that is generated station, that is generated 11 kV India, 3.3 kV, 3 kV different. Okay, in India we have the highest power generation, that is 11 kV only. Okay, whatever generated there, we transfer that amount of voltage with the transmission line, so we'll get this due to the higher length between the consumer and the generating station, the voltage will be high. So due to that, so whatever the power is generated, okay, so that we can using that one, okay. So by using that one, so by using the transformer, so whatever the power is generated, that will be stepped out to the 132 kV, 400 kV, okay, that will be transferred to the through ACSR conductor, okay. So that is a primary transmission, okay, from 11 kV to 400 kV, 220 kV to 132 kV, that is a primary. So from primary transmission to secondary transmission, okay, here where receiving station will be there, that will be transferred to the from 130 kV to 32. Here step down transformer will be used here. So whatever the transformers we use at the primary and second. Okay, here we are using the different types of transformer, that is a three-phase transformer. In three-phase transformer we are using, that is star and delta. Okay, here the power generation. Okay, to step up the voltage we are using the delta type. Okay, delta to star, star to delta, we are different connections are there. We are using the star to delta connection in the step up transformer here. Okay, so why? Because we are using this one is, so if you use the star to delta, okay, it will be easy to transfer the, that is 4 wires to 3 wires, so we can save the one conductor. Okay, but coming to the here, that is 33 by 11 kV. Okay, here we have to use the delta to star. Okay, so delta to star, three-phase transformer, that is easy to convert the, that is three-phase 4-wire system. We can be having the neutral, so if we in split ends we can observe that, that is 33 by 11 kV line. Okay, so that is easy to transmit that one. Okay, we can give the single phase as well as three-phase power supply by using three-phase 4-wire system. Okay, so this is a transmission system. Okay, so up to the 33 kV, that is 130 by 33 kV, that is 132, 220, 66 up to 66 we can call as a transmission. Okay, after that, that is below from 66 to 11 kV with 400 volts, that is called as a distribution system. Okay, so this is about the distribution. So another is there, that is a switchgear equipment. Okay, in switchgear equipment, that is in generation and transmission, whatever the equipments we are using, okay, to protect that equipment we are using the switchgear equipment. Okay, so that switchgear equipment will be used for the protection of the generation and transmission lines. Okay, so that will be here. Okay, this is the overview of the power system. Okay, hope you will understand. So this is Vani Krishna signing off.